Now it's time. Good morning, everyone. I am glad to welcome you today to a new session of Mobile Heights speaker series with focus on intellectual property. My name is Carolina Garces and I am project manager at Mobile Heights. And today I will be guiding you through this interesting webinar. But before we start with the agenda that we have for today, I would like to inform you about the house rules. First, and very important, this webinar is being recorded and we encourage you to have your camera on, but in case you don't want to be featured, please turn off your camera. We highly recommend you to add your name and company's name in your Zoom alias. You can do this with the information that you will find in your chat. Today's session will have 2 main segments of each minute each, and you will have 5 minutes after each presentation to ask questions. Please use your chat to write your questions. At the end, we will also have 5 minutes extra if you would like to have an open discussion. Finally, you will find this webinar on our Mobile Heights YouTube channel, and you can also find this presentation on our webpage. This is part of IP series seminars organized by Mobile Heights in collaboration with our members HØIBERG, Clarkson, Brann, and Zacco. All of them recognized IP law firms in Sweden and also in Europe who will be sharing their knowledge and best practices on intellectual property. And today we welcome HÖIBERG, a full-service patent agency providing counseling within areas of intellectual property. This includes patents, design, innovation management, technology transfer, business development, but also patent portfolio evaluation. And I am glad to welcome you today, Kristian Henningsson, a partner at HÖIBERG. He will guide us today through the patenting of computer implemented inventions and will explain how software can be protected and which strategies are available. Kristian is a European patent attorney, a European design attorney, and also holds a master in electrical engineer and an LLM in intellectual property. Welcome, Kristian.
Thank you very much. Should I start the presentation?
Yes.
I will do so. Can you see my screen now?
Yes, we can see it.
Is it the right one? No? Yes?
No, I think this one is,
oh, I'm sorry.
Should be the other one.
Yeah.
We're going to first talk about patenting of software. Yes.
So now is the right one now?
This is the. Can you go to the next slide?
Yes.
Yes, this is the right one.
Okay, great. Okay, thank you very much, Carolina, for this nice introduction. I will be presenting patenting of software and then some further areas within patenting of software. You can say AI and mobile apps. And it will actually be a continuation of the first session provided a couple of weeks ago by my colleagues at Zacco. They gave an introduction about the 360 perspective on IP as digital assets, and I agree with that, with the approach that they presented very much, that you have to take an overview of the whole IP and therefore I will try to continue as much as possible on what they said actually a couple of weeks ago. But this time we will be more specific, and I will talk about the patents specifically and software, but you should keep in mind that it should be seen as a part of a larger picture. The agenda has already been shown, so we will have 20 minutes for more general software patenting aspects, and then another 20 minutes on AI and mobile apps. I think it's a mixed crowd today, so it will be somewhat challenging to find the right level so that everybody is happy, but I will do my best. I think we will start out on a relatively basic level and then increase it gradually. And maybe if there are any patent attorneys, you will find the first part's boring, but on the other hand, I will get as much people as possible to understand everything. Yeah, Karolina already presented me. My name is Kristian. I used to work in the industry with technology development for a long time. I'm basically an engineer in electronics. So I worked for a number of years with developing hardware and software solutions. Then at some point I moved over to the patent, and I took this law degree and also was trained on the patent law specifically. So nowadays I spend my time assisting companies in protecting their inventions and trying to maximize the value of their IP generally, and more specifically in patent. So we start up with some fundamentals. A patent is basically a monopoly that for a given amount of time. It lasts for 20 years. I think the most important learning of this slide is that is the second bullet. It's a right to forbid others to exploit the invention, meaning it's not a positive right. This is a common misunderstanding, that if you file a patent application, that would give you some kind of right to exploit the invention. It doesn't actually, because it's only a negative right. So if you invent something and you patent it, you can prevent that others use the invention. That's how it works. The other way around is that if you put a product on the market, you then may infringe others' rights, and that's completely irrespective of whether you have patents on your own. That's called freedom to operate, where you actually have to look at others' rights, and that's not part of this session. But it's good to know just that what a patent is and what it gives you. So we move on. So here are the basic patentability requirements. This is good to know when we move into to software patents in a while. So the first bullet is patentable subject matter, and this is it's different in different countries. In Europe, for example, you basically say that okay, you can patent everything except, and then there's a list of things you cannot patent. For example, discoveries and theories and ideas, and also mathematical models that will be relevant for AI that we will talk about in a while. It actually also says that you cannot patent programs for computers. So this is of course very relevant for software patenting. The law explicitly says that you cannot patent computer programs. So what does that actually mean? I guess some of you figured out that that's not the whole truth, that we can actually patent it, and I will explain how. Second requirement is novelty, and that's quite intuitive to most people, I think. If you patent something, it has to be new. So you need to come up with a new solution for a technical problem, basically. And that makes sense, that you cannot get a patent on something that already exists. Inventiveness or non-obviousness, as it's called in the US, it's more of a subjective criteria, meaning that that you have to consider the invention or the progress or the technical difference compared to what exists, and then judge or assess whether there is something inventive in it. And that's of course a bit subjective, but on the other hand, there is obviously case law on that has been has evolved for a long period of time. So so there are rules for how to deal with that as well. We will not go into those details very much in this session, but it is a complex area. The fourth one, industrial applicability. That is that you're supposed to use, you're supposed to be able to use the inventions for some industrial purpose, and that's a quite broad term actually. And this, I think, this fourth bullet also excludes that you cannot patent things that are not physically that violate physical laws, so to say. Okay, let's move on. we will try to continue based on this to software patents now. So the starting point here is that computer programs, that's basically text that is protected by copyright. So that's already done when the moment you write the code. And as I said, in the European Patent Convention, programs for computers is excluded from patentability. However, the law also said as such, and that has a quite important meaning in this case. Let's see. Okay, we can continue with this one. So, so when you talk about software patents, I mean, there's nothing really called software patent. It's in European law, at least, it's called computer implemented invention. And I think there's an important difference here that it's not a software, it's not a piece of software that you protect. It's more the functionality of the code. So it's a method usually that is implemented on a computer, and that's a different. So this is actually what this slide is trying to say, that the software patent, that's something it's a term that we use. We all often use it because it's I mean, it's a convenient term to use, and we understand what it means, but it's not really true. It's somewhat misleading. So now if we go into the, I mean, now it's getting a little bit more detailed. We can get into the to the EPC, the European Patent Convention, and look at what it says. This is, I mentioned this on a previous slide already, that some things are excluded from patentability. And as you see in C, it says that you can actually not, the method for doing business and programs for computer are excluded. And as you see in the end of this slide, it said as such. So this means that programs for computers are excluded from patentability as such. And I think this this was drafted a very long time ago, maybe 40, 50 years ago, in the 70s. And at that time, I mean, computer program was not used in the same way as today. So I think this exclusion was that when countries drafted this together, they sat down and said, okay, this it doesn't make sense to really that we can patent software. So they put this on the list with our things as well, like scientific theories and mathematical models and things that should not be patented according to countries. These were excluded, but then they gradually found out that, okay, but yeah, that doesn't really make sense either, because you can patent a method for doing technical things. And wouldn't it then make sense that you can also patent a method basically doing that, but implement it on a computer? And then the case law showed for evolved during decades, and now it's I mean, it's very much accepted that you can actually patent computer implemented inventions. So we will proceed. So when is it then possible to do, and why? Because it says that the law says that you cannot patent computer programs. Well, technically, you could argue that, okay, this is how it started. Somebody said that, okay, if I put instructions on a computer, it is inherently technical, because when you execute an instruction, there will be some ones and zeros propagating in the computer, and so on. It's actually, and there will be electrical currents. It's actually technical by definition. So in that case, one would think that, okay, but then why wouldn't I be able to patent everything then, or all the software? So that was a good question. And then there came out these landmark decisions with IBM. They're frequently cited today. Where it was decided, okay, this doesn't make sense either. There needs to be something called a further technical effect, meaning that, okay, if you implement something on a computer, it needs to somehow have a connection to the real world or something technical. And I would give you some examples of this. It may be a bit abstract at this point, but from a law perspective, there's some hints in the rules of EPC about what the technical character is. So it must relate to a technical field, it must concern a technical problem and so on. But it's still not really that clear if you read just the law. So for this reason, after this landmark decision, there have been many appeal decisions in the EPO Board of Appeal. EPO Board of Appeal, that's like the highest instance within the internally within the EPO, and those boards they're trained with patent law, and so they've been dealing with this for quite a while now. In the end, it turns out that, as I said, that you need some kind of connection to sensors for controlling some real processing. There needs to be a further technical effect, and in order for you to understand this a bit more clearly, I'm now listing these examples. You can, for example, control brakes in a car. That would be a perfect example of something that you can patent. If you have an improved method of doing that, that would improve the functionality of the car. It's a very good example of a definitely a technical claim that would be possible to claim. In principle, it's nothing else but a piece of software, but you can patent it. In telecom, you have all this software related to communication that is obviously also patentable. You see a lot of it. And some other examples are secure data transmission and resource allocation in an operating system. And I mean, other standard examples would be, for example, image processing. You receive an image of something, either of it could be a photo, it could also be an image of some I don't know what I would take here, but and then you process the images, and then you extract some information, or you do something based on this. That is also good examples of what you can patent, and examples of what you cannot patent. Those are business methods, and I mean, good examples are when you just in fintech, for example, you try to improve algorithms for predicting stock prices or something like that. We also have a number of examples here. New rules for auction schemes and those kind of things. Also, I think some language, some translation engines and things like that could also be difficult sometimes. It depends. If it's part of interpreting real speech, for example, then it's certainly possible. But if it's just some text that you have in a database, and then you process that and you get some other text out of it, and it's typically difficult. Also, another thing that is difficult to patent, software that is difficult to patent, is a good example is that you have a known method, something that has been done manually for a long time, and now suddenly you figure out that, okay, but this process could actually be implemented as part of a computer program, but it's in principle nothing new in it. You just implement it differently. That is typically also very difficult to patent. Okay, so I keep getting back to this technical character, and that's for a good reason, because it's I mean, to some extent that's all you need to know about patenting of software. You need to really to link it to some technical process in the real world that either has, you will need some input in forms of sensors or some real technical input, or you will be able to use the method on something technical. That is really how it works, and that's what you should always ask yourself. If you have an invention, you should try to, as clearly as possible, explain what is new and what is possibly inventive, and also when dealing with software, if it's technical or not. And if you have an idea, you can of course always contact your patent attorney to discuss this, and they should have a good idea. Then there's some areas that are always interesting to follow, and that's for example simulation and modeling. I mean, to some degree, in my mind, those are a bit like mental acts. If you simulate something, it's not really happening in the real world. It could be a game or whatever. And to me, it doesn't really make sense that these are patentable. There's some case law being involved in that one as well. But usually they're quite. I would say that they're. I mean, they are accepted at the moment in Europe, that you can do some simulation. For example, if you have a circuit, an electrical circuit, and you simulate the behavior in it, that seems possible to patent, although it's in principle just a mental act to some extent. I think it has been accepted because there is the connection to the physical world would be that, okay, you simulate something with the intention of finding out how it would work if you, for example, implement this circuit. And the moment you implement it for real, you will have this information based on the simulation. So that would be the argument then, that it's actually, there is a connection. So I would say that for gray areas like this, you can try it, and I think most of the time it will work. But you can always expect that, of course, that yeah, if this would end up in a court case at some point, it will be challenged for not being technical and so on. But I mean, it also depends what you are going to use the patent for. If you get back to the bigger picture, will you actually use the patent to sue people? Well, maybe not primarily. So maybe you will license it anyway and make money out of it that way, or you will use it for other things commercially. So it may make sense anyway. You should always, I'm getting back to that all the time. You should always have this bigger view of things. Does it make sense to patent it really? So slowly getting to the end of this first part of the session, I think we can conclude that software is patentable, just that it's called a computer implemented invention, and it needs to be technical. That's really the take-home message of all this. I will also say something about the US, because I mean, this what I explain now, that is mainly the European approach. It is very similar in most countries in the world. That it works this way. In the US, it's slightly different. So we will have actually there's I think we will. Yeah, I can say a few words about this. I think we have time for that. So now again, should you patent software or not? Well, that's a very big and complex discussion. I think most of you, or many of you at least, will say that, okay, it's not worth it because there's some disadvantages of it. For example, it will be, maybe it's too narrow. So the third line here, which says that, okay, there may actually be several solutions. If I just patent one of them, wouldn't be easy for a competitor than to just do some other solution of it. Well, that's true. It's also true that if you draft the claim too narrowly, so it may be possible to circumvent. It may also be difficult to prove that somebody is doing this. So why would you then use the patent if you cannot, in practice, stop anyone from doing it? Okay, so these are possible disadvantages. It's not always the case, because, for example, sometimes you can detect, because you know that it will be visible in an application what an infringer does. So you can actually prove it just by showing what he's doing on the screen, more or less. So it's not always true. But I agree that most of the time it's difficult to get the value that of a software patent that is really strong. There are also advantages and opportunities for doing it, and you see a lot of companies doing it. I mean, big companies in telecom, for example, they don't patent softwares for fun. I mean, they do it because they make a lot of money out of it, and they can tie it to standards in some cases, and they can also you can also draft the claims intelligently so that you cover a lot of it, of the functionality. Usually you have in a method, you have a number of steps, and if you try to generalize the steps that are not crucial for the inventive part of the method, if you generalize those, the claim could end up being fairly broad, and then you try to be more specific on the part that is really inventive. So I think it's I mean, this is part of a part of the larger of the bigger picture, and in the IP strategy, that you look at all the assets, you say, okay, does it make sense to protect this? Can we keep it secret? Can we rely on trade secrets instead? Questions like that. That is, you always have to look at it from a broad perspective. So that is a good thing that we can use from the first session of these 4 sessions. And I know also that one of the sessions later on will be on trade secrets. So that would typically be something that you can consider in the case of if you have inventive software. Should I keep it as a trade secret if possible, or should I patent it, or should I do something else? I can. Do I have time to take this?
Maybe 1 minute, so we can take questions.
Yeah, makes sense. I think it's okay if we go just a little bit over time on this one, because the second part is possibly a bit shorter.
Okay.
So here we have the I've talked about the European approach, which is the same for most countries. And then in the US, it's completely different, but in the end, kind of similar anyway. In US patent law is very old, and from the beginning, everything was possible to do in the US basically. So so in the 90s, there were all kinds of software patents, and almost at an abusing level, I would say. And you had all kinds of business methods and things that would never be passed today. And under the Obama administration, at some point, there was some cases in the Supreme Court where they scrutinized this a little bit more and came to the conclusion that, okay, it doesn't make sense to be able to do all this. And there were some really decisive cases. One were very famous in 2013, I think, called the Alice decision. Which has some very strange claims on, for example, interest rates and things like that. And then it ended up that the court said that basically that, okay, you cannot patent what they called abstract ideas, and there was long explanations why that is not possible. And then there was a period of time after in the Alice case that it was really difficult to patent. I mean, quite a lot of software invention had problems during sometimes. And then there came guidelines a couple of years ago, and now it seems to be to some extent convergence between USA and Europe. I think they're going in the same direction. We can get similar claims granted in US and Europe these days, but based on they started out from very different positions. But I think it's we end up with more or less similar approaches. Okay, sorry for taking me a few minutes too long there, but we can go on with the questions from now and start a little bit later on the second one.
Yeah, that's perfect. We have already a question, but I encourage you to write your questions on the chat so Kristian can answer them. The first question is from Per Henningsson from Lund University. When looking into software patents, they often contain drawings of processors, memory, and other basic components to enter it in technology. Will that develop towards more modern view of computer systems, where we, for example, look at operating system as the platform, a piece of software it is operating on? You can find it on the chat also.
I'm not sure I understood that question.
So let me explain. So when you look at there are often these drawings where they explain, here is a processor, here is a piece of memory, which is to us computer scientists and computer engineers is very old-fashioned and basic, but that's the physical level. And then they anchor the methods, which is the real invention to this physical level. So is there any, but from a real design perspective, we build these on top of several layers of software, where somewhere down in the basement there is a physical device, but it's layers of software. So is there any development towards actually having the description in the patents more up to date and realistic, and still being able to motivate it as being anchored in the technology?
Yes, I think it's just, I mean, that's already done basically, but I agree that typically in a patent claim, which defines the protection, you usually write things like, okay, you have a method for carrying out the process, and it's when you in a system claim, you may, for example, have a processing unit configured to perform that claim, and then we write in the applications that, okay, but this can be done in several ways. Of course, its processing unit is extremely broad in this sense, and we try to cover all the possibilities in the description to say that this is actually how it's going to be interpreted. It could also be on a cloud, and yeah, whatever processing unit it may be, basically. So that is not a big issue, I think. But on the other hand, you have all these issues about what about infringement? If you have something carried out on a cloud or in another country or something, is your protection in here locally, is that good enough? And that's obviously a very complex question.
Yeah, the issue I have had is when I've tried to use it with students in courses to show patents, and it's very hard for them to capture that there is some novelty in this when it's that old-fashioned in the sketches. So there is an issue of communication, but maybe that we have to compensate for that in our teaching.
Yeah, I think the key is really to go to the claims and check what this functionality is. Is there something smart in the way that it's implemented?
Okay, thanks.
Do we have more questions on the chat? I actually have a question for you, Kristian. As you explain, a patent protection is not the positive right to exploit an invention, but the right to forbid or prohibit others to exploit the invention. And I imagine that when it comes to competition, a patent will be continuously facing claims from competitors who actually want to use the invention. How complex are the litigation processes, and how expensive is it when a company wants to deal with this question of patenting or not patenting, and like all the costs that they will imply on the time?
Well, the litigation costs, those are huge, and but it happens very rarely, actually. I mean, the patent costs are much less than that, but it's still considerable cost for example, startups. It can be in the order of maybe filing a patent application would, for example, be in the order of 50,000 Swedish kronor, and then prosecution on top of that could end up in several hundred thousands, depending on which countries. Litigation is another story. That's many millions, I would say. But most of the time, you have these patents to I mean, they will, even if you don't sue people based on them, they will keep people away from your technology, hopefully. And you can use them in other ways as well. You can, I mean, if somebody want to use it doesn't mean the technology doesn't mean that you have to sue them. They can also have a license from you, or they can buy the technology, or they can buy components from you, for example. There are many things to look at it. And usually we file a lot of patent applications, and very few of them end up in court. So there are huge costs for that in the end, but it's also many ways of avoiding it and still making use of the patent right.
Okay, so it's 11:35, so I think we can start with the next segment then.
I will do so.
We will talk now about artificial intelligence and patenting of mobile apps.
So does this look correct?
Yeah, we go to the next slide.
Yes, I will move on a little bit. Okay, here we go to smartphone apps then. Okay, this is there's actually not much different here compared to software, because what is a phone? A phone is a small computer, so it's technically speaking not a big difference to all of what I've said already. However, there more from a practical point of view, there's some things that we can that we can say here. For example, I think that apps are special in that they are typically implemented on a device that has a lot of sensors and capabilities of capturing things. That is somewhat different compared to an ordinary computer. So you have all these GPS and gyro and cameras and microphones and whatever sensors you have in the phones. And my experience here is that in the same way as you need any computer implemented invention to be technical and have a further technical effect and all that, which I described 10 minutes ago, you need to do the same thing on a smartphone app. And usually this means that you make use of the sensors in one way or another. That's at least my experience in the patents that we file on these. You may, in principle, also use it for controlling stuff as you do with other computer inventions. But most of the time, it's as far as I'm concerned, it's based on some inputs, and you do use that input to do something out of it. So here are some examples. I think a common example is that you do some image processing and video processing based on cameras, and you get funny applications based on that. Also, the previous slide where you could see there was like a go back. You see here that there is a light in the early versions of iPhone. I think there was a special app for controlling this flash light as a torch. Basically, you could turn it on and use it. I think that would have been patentable if it was new at the point. It's just an example. I don't know if they ever patented that. Now it's more of an integrated feature in any phone. But we move on here to some further examples. UI aspects can be patented in some ways. You can see that there was a big fight about this many years ago with I think it was Apple that introduced some ways of zooming in and out by using certain fingers on the screen. So that's also sensor inputs in a way, because you have a touch screen, and the way you touch the touch screen can make different things happening on the screen. And that was if we should talk about software inventions, I think they have to some extent they also have a negative reputation to some extent, and that's possibly because of these patent wars between phone manufacturers, where they had some really trivial inventions, in my opinion, that wouldn't really deserve such a big protection that they got. And I think as far as I'm concerned with this, I don't think that's the problem of the law and the fact that you can patent software inventions. I think that's mainly more a question of setting the bar to inventiveness too low. So in my opinion, you should have some quite high standards for accepting this kind of invention. Then they probably also would be more widely accepted by people. I think the best way of explaining these software apps is by giving further examples. So I took some real examples that I found by just searching the databases. The first one is, this is probably not new anymore, but it was patented some time ago, that you can actually move around in the building and you just use your phone to get some, well, we take pictures basically, or a video, and then it produces a panoramic view inside the building. That's probably something that many phones can do today. Second one is that I saw a method for using the phone to some kind of control in the computer game. So if you watch other people playing, you can be part of the game, and you can control how you see the environment, a little bit like some kind of virtual reality, I would guess. You've also seen examples in instead of using digit or a password to unlock the phone, you can actually make a little drawing in it, and that would work in the same way. And I've seen examples of biometric authentication. We approach your hand actually to a device, and that would scan veins in your hand and things like that. That could also be examples. But as you can see, and we always get back to that, it's you have these technical effects and these further and the technical character. It's always there, and as you can see, it's always based on some kind of input to the phone, more or less. I would also say that when people say that we get this question all the time: can I patent my app? Well, I think the answer is not that yes, you can patent your app, but you patent a technical feature in the app. I think that's the way to look at it. You don't patent the app itself. I think that's an important thing to know. Just like software, it's no big difference actually. But we get this question all the time. Can I patent this app? Also, an example of something that I think you usually cannot patent is when somebody implements an app or any software implementing, let's say, a platform for doing business. It could be, for example, something comparing whatever, insurances or something. That's probably not new anyway, but or a new social media platform, or a new platform for connecting people which have some specific disorders, and they can discuss in chats and so on. All those more platform-oriented apps, they're typically very, very difficult to patent because you fail to describe a technical solution to a technical problem. They're more, to me, those are more business methods or actually known technology that you just use on a different field. So yeah, I guess this information is in a way clear from what I've explained, but it's always good to mention this to people, because we get the questions all the time about patenting apps. And like I've said a couple of times, yes, it should be a technical solution to a technical problem. And if it's more generic and more platform-based, probably difficult. So how about AI? That's a very interesting, and both I would say it's both a simple and a complex area, because it's simple in the way that and the authorities around the world, they tend to look at it as software to keep it in that system somehow. and to look at the models as mathematical methods, basically, which is also true. So it makes sense from that point of view. So then that would also then mean that it should be excluded by definition as such. But again, if we can connect it to a technical problem, it should be patentable. So in that sense, it's pretty much the same as what we already know. But the thing with AI is that there's so many aspects of it. You can do so many things with it. So there will be inevitably there will be questions about, okay, can I patent this part, and can I patent some other parts, and that is still evolving. Luckily, there are guidelines both from the EPO and the USPTO on what you can do. So if you stick to those guidelines, it should be possible. But then, of course, you can also try to do a little bit more than what those guidelines say. Here's some of the aspects that I mentioned that you have to. These questions you can ask yourself. If the model is new, if you develop a new machine learning model, for example, is there anything in the model that is new or improved? The way that you train it is a typical way of adding something new on it, and the way that also that you apply it in the end could also be interesting. So I think, as always with software, it's very difficult, very important to get back to the question: what technical contribution does the invention make? And if you can answer that as clearly as possible, I think there should frequently be possibilities to do it. I think the reason why AI is such a big deal in this, we also get a lot of questions about that. It's probably that, AI has existed for a very long time, but now more lately it has been it has developed rapidly because of more powerful processing and possibilities to calculate things in the cloud and so on. It has been more accessible, and you have had models that you can train, commercial solutions that you can just feed with data and then get a trained model and so on. So it's much more available, and everybody uses it much more these days. And for that reason, the patent law has also been urged to develop a little bit in this regard. What else can we say about AI? I think the key really here is to look at, okay, so what do you actually do? So usually in a process like this, there is some kind of, you have to make a decision on what kind of model do you use actually. I've seen many variants of machine learning models and the models that you train. So you have to look at the model. How do you design that? And you also have to look at how you train it and how you use it. If you can add something to those steps, then there's chances that you can make it technical and you can patent it. I think what we sometimes see, and what is difficult here, is that you have some, it says in the end of this slide, that typical challenge off-the-shelf AI solutions. For example, if you go to Google, have their models that you can feed with data, and you just say, okay, I use this model, it's a standard model, but I figured out that you can actually use it on something else that nobody else did before. So I just keep feeding all these images to it, and I get a result, and then I use that. In that case, sometimes we have difficult to help such clients with the patenting of AI. I think usually we need some more inventiveness in the sense that, how do you, usually there's a problem, for example, that you don't have enough data. How can you be more clever when you generate data? Can you use the data more efficiently when you train the model? That could be something, and that's very frequently that we see something in that field. Also, the way you use it, if you can somehow apply it to a real task in a way that is a bit different from what you would just do by saying, okay, here's the problem, I solve it by applying an AI. You have to show it a little bit more in detail how you do this in order to be able to claim it. That being said, I think especially in the US, I think there's some possibilities that you can file such I mean, quite broad claims, and you can get away with it a little bit with luck sometimes, based on the examiner, how he looks at it, because they're not as trained as in Europe, I would say. In Europe, they're quite strict about what you need to do and how. And but on the other hand, I mean, I've seen many cases succeeding as well in Europe. If you just have an idea of what you're trying to do and why it's different compared to other solutions. I think one, if we're talking about pros and cons, like we did for software in general, if you do that for AI, you can't say that, okay, so how you have the same problem here. How do I actually prove that if I have a claim on a process for training a model, how would I know if a competitor has trained his model in the same way? And that's obviously a big issue that you don't in practice. So in that case, you will either have to hope that that it's a serious company that takes IP seriously and would, in that case, ask you for a license, or at least you can be sure that they cannot market their method in the same way that you do. And if possible, you can also try to have claims on the application. That is, my experience is that it's more difficult to have those claims, because all you will say is that you have a method for doing a specific task based on or with the help of a model that is trained a certain way to do it. And typically that is, the application itself is more straightforward most of the time. But maybe there's some people that know more about this than myself, and then I will of course be listening to that and try to take in why it would be different. Yeah, I think there's actually a lot to say about AI inventions, and I think it could be that, okay, so now if it's difficult to prove infringement of the training of the model, why don't we then just train it and try to keep it secret, and train it secretly in the cloud or some hidden software that people cannot reverse engineer, and then we just consider the value to be in the trained model, and we don't care about if people try to do the same. That could be one solution, and that somehow takes us back to where we started. This has to be part of a bigger picture. You need to look at this in several ways and say, okay, is the model the value part of it? Or can we protect the training, or can we keep it secret? And luckily, there will be a coming session on trade secrets. Maybe that could bring up this issue again, and what you, in that case, need to keep the model secret. I think that's the end of this presentation. We have a couple of minutes for questions. If you, I think there are really many things that I didn't cover in this presentation, and that if you have further questions to this that you don't want to ask today, you can always contact me afterwards and ask these. That is no problem. So I will stop presenting or sharing my screen now, and there will be 5 minutes for some more questions.
Yes, thank you so much, Kristian. Now is the time for an open discussion. So now you can rather write your question on the chat, or you can present your comments or questions directly. So we wait for a few seconds. I actually I have a question for you, Kristian, because we were talking about the alternatives that you have to patent software or an AI application, but my feeling is that nowadays technologies evolve very fast, and could be that software solutions, they become obsolete very fast comparing to the time that it takes to patent them. What is the strategy here when you decide to actually patent something?
Okay, then that's a good point, and that's also part of the strategy. I mean, if you decide to patent a software, I think it should have some minimum time for it to be interesting to do. I mean, if it's something that it changes all the time, then it doesn't make sense. Also, I mean, this is also a general discussion. If you look at if you want to patent something, it's always the case. If there's not enough money in it, then it doesn't make sense, because you spend a lot of money on patenting the solution, and then, I mean, there has to be some business in it. So I mean, the answer to your question is, if it changes too much all the time, then it probably doesn't make sense.
Okay. And another question that I wonder, because you explained that according to the law, there is not a positive definition of invention or technical character, and it leaves there a lot of gray areas for making this process a little bit more complicated for small companies, I believe. Is there any developments on the law to actually mind those gaps?
Right now? Not in the sense that I don't think the text of the law will not change because it's at least not in Europe, because that's something that has been agreed between many countries, and to do that again is it's almost impossible. So the law will probably stay, but this I mean, the case law is also part of the law. So this has evolved for a long time, and you basically know what the requirements are by now. It's very detailed, and we do a lot of it, but we know how it works nowadays.
So some companies are building knowledge up. So it's actually the collaboration of a lawyer is actually important. My last question, I don't see any other question in the chat, but I know that nowadays with companies who are leveraged with resources and knowledge about the patenting process, they have the possibility to create strong patent portfolios. What is the role of patents in innovation, based on this idea of the monopoly that you explained at the beginning?
Not sure I got that question. Can you say it again?
Because you have both sides of the patents, right? When you want to patent, you have to actually open all the knowledge and secrets. But on the other side, the process is a little bit complicated. So I have the feeling that those big companies that build knowledge around how to patent, those are the ones who can actually create this strong portfolio of patents, leaving the small companies a little bit outside. So the monopoly question.
Yes. Well, yes, it's true that the large companies, they have frequently in-house departments for taking care of this, and they have a big knowledge internally. I think if we work with startups, we typically work a bit differently, and we cannot expect to file hundreds of patents directly. So you typically try to really focus on what, if you need patents at all, then you focus on a few of them, and try to really cover the key aspects of the technology that you think can really. I mean, it's all about creating value and putting these companies in a better position. If you cannot file hundreds, but 3 patents instead, then you have to select those that you think you can do a difference for the company.
Okay, so it's important to build a strategy before you start all this process.
Yes, I think so. It's a continuous strategy work.
Perfect. I want to thank you, Kristian. I think that it has been very interesting and inspiring presentation. you can take contact with Kristian directly if you are interested or you have more questions. And before we say goodbye, I just take the opportunity to invite you all to the next IP webinar series, which will take place on February 10 next year. At the same time, where Porter Clarkson will be presenting about trade secrets. So thank you so much for today, and thank you, Kristian. We see you next year.
Okay, thank you all.
Bye-bye.
Bye.